Hey everyone, this is Developer Ash, and today I have brought to you a little advanced project of data science. Of if you have a company, then you can actually predict which of your employee will quit your company. And not only this, you can actually predict of like for your college or for your school, like how many number of students gonna take admission in your school or in your college or wherever you study next year. Okay, like how many number of students gonna take admission in your college next year. Okay, so if you just do this project, then I bet you can do more advanced project like this. Okay, prediction of what's gonna happen based on the previous data. Okay, based on this previous year's data. This is a little more advanced data science project. So I suggest you to do first projects like heart disease prediction. Link in the description, which I made tutorial just few days ago. Just do that project, okay, and then just come to this. So let's just introduce. Let me just introduce you. First, we just gonna import the data. Okay, we gonna use like two data here, two CSV files. This is first one is just like employee ID, number of projects, average monthly hours, time spent, company, work accident. Left, this is our y target variable. Okay, and what y target variable is, I'm gonna explain you later. Okay, promotion last 5 years, department, sales, support, IT, management. Okay, salary, low, medium, high. Okay, then we just gonna do some numerical analysis of it's like we're gonna see if it contains any missing value or not. Then we just gonna do some, after doing some numerical analysis, we just gonna do again, like we're gonna import another CSV file, this one. Okay, this one is employee satisfaction evolution. Okay, like see it in this CSV file we have satisfaction level of each employee. Okay, like see it was like the same employee, for the same employee above we saw na 1003. This is their data, and in second CSV file we have their satisfaction level, and satisfaction level last time it was evaluated. Okay, last time when the last evaluation was done, last time as compared to present time. Okay, so right now their satisfaction level is for this employee 0.38 and last time it was 0.53. So of course, based on this we gonna predict if this employee will leave or not. Then after this we just gonna join those two CSV file. Okay, like this. So now previous data and satisfaction level, last evaluation also. Then again we're gonna do some numerical analysis. So see, we will find some null value here. So 14,999 got none null, means they contain not any single null value, but 14,972 here in satisfaction level and last evaluation have non-null value, but remaining 27. Okay, total rows are 14,999. Okay, and there also total rows are 14,999, and among those 14,972 got none, means non-null value, but remaining 27 got null value. So we're gonna deal with that too, how to deal with null value. Okay, this you can say this nan value like this. Okay, this nan value means that values like which just don't have any value. Okay, not even 0, not even 1, nothing. They just don't know what were the satisfaction level and last evaluation of you can say employee number 3794. They just don't know. Okay, so then we just gonna do some more numerical analysis, and then we gonna visualize the data. Okay, we just gonna do some 4 to 5 this plots, and then we're gonna do data pre-processing. We're gonna do two things: level encoding and standard scaler. For decision tree, we're gonna we are using two algorithms. decision tree in KNN. For decision tree, we not gonna do standard scalar. I'm gonna explain you what is standard scalar, and after just doing some data pre-processing, okay, we just gonna split into training and testing, and then we're gonna train our model in decision tree, and then we're gonna predict on this X test, not only in X test, but we actually gonna predict on our custom data. Okay, our custom data, and it will tell us that employee will leave the company or not. Okay, then we gonna know what was the most important feature. Okay, like we got satisfaction level in like among all this point, among even in salary, okay, even in salary and their department, if they belong to IT or sales. Okay, satisfaction level is the most important feature of why any employee stays or leave the company. Then we gonna come to our second model, that is KNN, and we gonna do data pre-processing for this. Again, standard scalar, standard deviation. I am gonna explain you why we need to do standard scalar. Okay, just be with me till last, and then we gonna predict on k nearest neighbor on same thing, and then we're gonna find what should be the best k value. Okay, like this, and then we're gonna predict on custom data, and at last we just gonna see, like in this case, in this particular project, decision tree did better job than KNN. Okay, so let's start the project. Okay, so let's start the coding, and I'm just gonna first of all import pandas. Why? Because we need to play with data, so we will need pandas, and I'm gonna import our first CSV file. As we know that we're gonna use two CSV file, and later on we're gonna merge them to do our data science project. See, we have employee number which we're gonna drop it later. Okay, we don't need this number, and we have like, and this is employees data of like about like employee number 1003. It has like this data of like number of projects this employee did is 2, number of average monthly hours 157, time spent in company in years, okay, 3, work accident they did, any kind of work accident they did, no, then they left, yes, 1 means yes, and 0 means no. Did they got any promotion? No. Department, employee number 1003 worked in sales and his salary was low. Okay, so in department we have various kind of departments like sales, technical, support, IT, management, accounting. Okay, and in salary we have low, medium, high. So these are the employee numbers and these are their datas. Okay, and then we're gonna add another CSV file which is gonna contain satisfaction level of these employees, and then according to that we're gonna predict the data. So this gonna be our target variable. Okay, like this left, like see, all the things, all the parameters up except this. Okay, except this, apart from this, excluding this, all the other parameters are our training data, or you can say the data which are required for predicting. Okay, and these are the predicted values. Okay, these are the actual data, you can say these are the outcomes of what happened if any employee who had number of projects 2, okay, and who spend average monthly hours this much, and you know all the other parameters. So what he did, he left. Okay, and we gonna train it like this and see. And if any company who's who did number of projects 4, okay, and average monthly hours these, and 3 years spent, no promotion got, and he worked in support department, his salary was low, but he did not left. This was G was the left, I think, of column left. No, F, no, but he did not left. See, where was it? I don't know, but he did not left. Okay, so what happened? He did not left. So we're gonna predict our model to take all the data. Okay, and you can say memorize this or whatever you want to say. But if any person, if any of the employee comes under this parameter, okay, except this left one, okay, except this left, okay, this is our target variable. So apart from this, if any of the employee comes under this parameters, then model will predict that that employee will leave the company or will remain in the company according to the previous outcomes. Okay, means if you enter the input, like if for any employee, if he has worked on number of projects 6, average monthly hours 247, 4 years he has already spent, work accident he did nothing, promotion he got nothing, he worked in sales and his salary was low, then chances are that he will leave the company because the person who worked previously in the company has also left. Okay, that's the whole scenario. Like this is the whole scenario. What's like how this project gonna happen, and you have all the parameters and you have the data of outcomes of like previous 5 years, 10 years or whatever, and according to that we're gonna predict what's gonna happen in the future by if you like according to the previous data. Okay, so let's start. HRDF, I'm gonna just import like this. HRDF is equals to pd dot read. This is our CSV file, so CSV. If it's an Excel file, so we could have write read Excel. Okay, R, why? Because Python takes this forward slash. Python takes this forward slash. No, so you don't want to do forward slash in like every other sentence. Okay, so you just put R and it will take it as forward slash. And what is our file name? HRData.csv. we need to write like this, HRData.csv. okay, CSV. Okay, now let's call this and your data frame is ready. DF. See, what is the shape? 14,999 comma 9. No, yes, like if you just want to know this shape, no, shape, then see 14,999 means from 0 to 14,998 means 14,999. you have rows. Okay, and how many parameters you have? This much, which we gonna drop employee ID later, not right now because we have some use. And these are all our X and this is our Y, that is target variable, like previous outcomes. Okay, and if you want to know the size, then HRDF.size X into Y, you will get this. So we are like after importing data now, here we are doing what? Numerical analysis. Okay, we in this tutorial our main focus gonna be doing on numerical analysis and then predicting the data, not on data analysis, you can say, like not on visualization of data. We're gonna import 2 to 3 graphs. Sorry, we're gonna create 2 to 3 graphs only, but not more than. Okay, numerical, because that's not the main focus. We're gonna make some 2 to 3 graphs like this now, like this. Okay, so that's gonna come under data visualization also, data analysis, like in the whole term, you can say. So we are here and let's move forward to see if this data frame contains any null value. Why? Because if it writes na NaN means this has no value. Like see, promotion lasts 5 years, 0. But what if this data don't know, like what if this CSV file doesn't have data for that? Means NaN means simple, like you have the data, but for some parameters, for some features, you just don't know what was the outcome. Okay, so NaN. Okay, so how to deal with that? How to deal with missing data? We're gonna see further. That's why this project is little more advanced, because we're gonna deal with missing values when we're gonna import this second file. Okay, now let's quickly move forward and hrdf.info, and you can see like this. See, non-null means all the 14,999 rows contains no null value, non-null. Okay, it has some values in every column. Okay, like it has some values, but it doesn't have any none value. Okay, so let's move forward, and now let's move forward and see how much unique value this data frame has for department columns. Okay, like we have sales, support, technical department, IT department. Now let's see now how much it actually has. Okay, so we're gonna call department from HRDF. So that's how we call department dot unique. That's how we call unique, and see, it's right now processing the data, and same till it's processing, let me write HRDF, what we gonna call salary, na salary, and dot same unique. All right, see, in department we have sales, accounting, HR, technical, support, management, IT, product management, marketing, and I don't know what is this, and D, it might be something. Let's see if it has any meaning, or like it is not. It has, I think I just saw now somewhere. Yes, it has. It is like, it is a kind of department, but I don't know what. But all right, and we have salary of low, medium, high. Okay, so right now we are doing what? The numerical analysis, and after this, let's import another CSV file. Loading our employee satisfaction data, and it contains null value. Let me show you. We're gonna have this CSV. Below one is same. Okay, and let it open. Okay, it has some null value. Let's see, it has some missing data, na? So I'm gonna show you how to deal with this. And we have satisfaction level of like 0.8, and in last time it was 0.53, and like see, for employee number this we have like 0.8, and last time it was like 100%. So you can see like for some employee satisfaction level is decreasing, and for some, let's say it might say, let's say for some it might be increasing, but where I even need to find out. Let me just go down. Yes, see, right now satisfaction level is 0.91 for employee number this, and at last time it was 0.71 only. Okay, so for some it is increasing, and for some it is decreasing. So according to that we can predict, okay, like if anybody comes under this parameter, then he will quit the company or not. So what to name it? That was HRDF. Now for satisfaction, let's say S for satisfaction DF on. And path is same, so I'm just gonna copy this till here. PD dot read. I should silence my mobile here. Dot read CSV, and there we go. Okay, and this is our name. Let me just copy this name. Dot CSV. Oh, okay. Again an error. File not found. Why? Okay, so because this is actually an Excel file. See here. Okay. Employee satisfaction evaluation, Microsoft Excel Word. This is in Word. Okay. Worksheet. Okay. And HR data was Microsoft Excel Corporation. Sorry, comma separated values. I named both of them incorrect, but alright. Microsoft Excel comma separated values. This is a CSV file and this one is Excel file. Not much different, not much difference, but we just need to do two things here. We just need to find Excel assets, means we just need to define for Excel file and read Excel. Okay, now if I just call this, and here we go. Now what we need to do, like see, data frame is ready. Okay, means if I just open this, like see, we have this Excel file is opening, and see satisfaction level and last evaluation. Okay, for each employee. Okay, so we have like what is satisfaction level here is just like right now at present what is the satisfaction level of employees in that company, and what was their satisfaction level last time, when like say last year what was their satisfaction level for employee number 1003. Last time it was 0.53 and this time it is 0.38. Okay, so low. And so now let's merge these two together. Okay, like this. Let's just merge them together. And the good thing is, because in this CSV file, okay, like see for each employee some data are in this CSV file, like number projects, average monthly hours, time spent in company, promotion last 5 years, work accident, department, salary. And for same employees 1003, 1005, 1486, for same employee some data are available in this file, like satisfaction level and last satisfaction level. Last time it was evaluated. Okay, so now let's just merge them together. Okay, so let me just first write merging and joining. So first let me just write main DF, means this is our main data frame. Okay, I'm naming it main DF, and HR, like from HRDF I'm gonna call, like I'm gonna work on employee ID. How? Let me just tell you how. Okay, employee ID, yes, how? Employee ID and this employee number is same now, so I'm just merging them together to be one. Okay, so see, there is no employee has anywhere. Okay, so let's merge them. Okay, and employee ID. From HRDF I'm calling employee ID to join which data, SDF, okay, and with what should be the common there between them, employee ID and this employee has, you can say. Just copy this. See what's happen if I don't call set index. Okay, data frame object is not callable. Why? Because we need to do one thing here, is set index, because we want it to be common. Okay, means in the same index, so it should be like same index. Okay, join set index. Now let me call the main df and see main df. See, employee ID and employee has is now same, okay, in just one column by this name. Okay, but now let's just see it is not looking that much good. And if you just want to find a shape now, okay, it is 14,999 comma 10. Okay, means it has now 10 columns, you can say. What we need to do is we just need to do main df is equals to main df dot reset index. Okay, now if you just call main df now, see it is now main df with 11 columns, because earlier you just saw now the main df dot shape was not recognizing this column. Okay, it was only recognizing that this all the columns that was like, you know, above this one now. So right now these are all in the same line, so this is now counting this you can say this column also. So now it has the shape of 14,999 with 11 columns. Okay, so now this is our main df which we're gonna work, and you have this much of data: employee ID, number of projects, average monthly hours, time spent in company, work accident, promotion last 5 years. I'm not counting this one because this gonna be our target variable, that is why. Department, salary, satisfaction level, last evaluation. Enough to predict if any employee will quit your company or not. Okay, now let's see how much null value this main data frame has. So main df dot not doesn't know info, sorry, not null, I don't know what I'm doing. Alright, it's info and see non-null means, see here 14,999 has is non-null, but see 14972 columns is non-null. Okay, these are non-nulls, but how many columns does we have? 14,999, and 14,972 is non-null, means other than that, means if you minus, then it will come like 27 columns around is a null value, has a null value. 27 rows, you can say, so not column, 27 rows has null value. Okay, now let's find out what are those rows. Now let's find out main df, you can say, and from like what we want main df, like we are making the data frame of main, so that's why main df we are calling, and under that what we want is whatever the null value is. Okay, dot if any null value is there, then show us from axis 1, means from rows. Now if axis is equals to 0 means from columns. Okay, now just see what I'm doing. Okay, see here see NaN. Okay, means I created data frame with respect to like main data frame according to that now, which contains satisfaction level and last evaluation also, and main DF. And what I called is, I just want to see only those values which are null. Okay, and from where? From rows. Axis is equals to 1 means rows, and axis is equals to 0 means columns. Okay, so from rows, like 18th row of that main data frame. So 18th, from 18th row, employee ID you can see 3794. Okay, and from 18th row we have a null value, and in satisfaction level and last evaluation, like both values are unknown, you can say. Okay, like even if they have 0, then all right, they don't have any satisfaction level, they are not satisfied at all. Last evaluation they were not satisfied at all again, but these are none value. Okay, means we don't know if they are satisfied or not. Okay, so how to deal with this? Let's see. How to deal with this? First of all, what we're gonna do is just we're gonna fill those columns, those, you can say, those boxes with the average, with the mean value of other satisfaction levels. Like we gonna calculate the mean of this satisfaction level. Okay, so we're gonna just calculate the mean of like this satisfaction level, and then we're gonna fill, like, see, we're gonna calculate the mean values of all the satisfaction level. Okay, and none it will not calculate, and we want to fill those none values with those mean values. Okay, so see, just follow me what I'm doing. Main df dot describe, from describe function we can actually do this. Okay, see, count, mean, standard deviation, minimum 25%, 50%, 75%, maximum value of satisfaction level is 100%. Okay, 1.0 means 100%. And what is the mean here? 0.61 means 61% are satisfied. Means every employee on an average are satisfied with 61%, like. Okay, and last evaluation they were satisfied 71%. Okay, so we're just gonna fill them according to this. So just see. Okay, main df dot fill now means fill those none values. Okay, so fill now, and if we wanted to drop now, then we can just use drop now. Okay, so means it will drop all the rows which has none value. Okay, so you will be like, you will be having no none value at all if you just drop it. But we don't want to drop that, we just want to fill those gaps now. So sorry, not like this, but fill now, fill none values of what? Main df dot mean. Okay, mean, and we want them permanently, so in place is equals to true. If you don't call this function in place equals to true, then it will just show you that it has filled, but for only this block. Okay, so you need to call this function to fill them permanently. Okay, to make the actual change in the main data frame. Okay, so if you just call this now. Okay, now if you call this one again, so just see that now, see, you don't have any null value because it has filled those gap. Okay, in the main data frame, what it filled those none value with the the mean of main data frame with respect to their columns. Okay, so in the main data frame we have satisfaction level, and like if for an example, if this column contains none value, okay, so what we did is from main data frame we called mean function to fill those gaps. So with respect to their columns, it would have just calculated the mean like this, okay, and it will fill the none value of this column only. Okay, so satisfaction level has was having mean value of 0.61. So we called main df.mean function to fill those none values with respect to their columns. Okay, so satisfaction level was having 0.61 mean value. So now if you just call this 18th index now, so see 18th index, what 18th index is having. Okay, let's see. Earlier it was having that 18th index was having, I could have none value of satisfaction level and last evaluation also. Now they are filled, so let's just call them main df dot loc means we just want to call the columns by their names. Okay, if you want to call them by their index, like 0th index, first index, second index, so you can just use iloc function. Okay, but in main df, okay, main df we want to call employee id column, that's equals to let's say employee id column. What was it having? 18th number 3794. okay, so it will show you the only that row of employee id number 3794. okay, and it will just make the data frame according to this main df. okay, see 18th number column has now the mean value of means the value is of satisfaction level is 0.61. okay, and last evaluation satisfaction is 0.71. that was the mean value of last evaluation of all the rows. okay, so means it will just calculate the mean value of every column and you can just fill those gaps, okay, with respect to those columns, okay, by their mean values. If you just want to call, if you like, see, not for only 18, but let's call this 1340, then it will show you the same result 1340. I think it was see mean value, okay, 0.61, 0.7. so that's how you can fill those gaps. Let's move forward and removing those employee id which is now no use, which is of now really no use. We just wanted to call, okay, like we just really wanted to call according to this employee id. So now I don't think we gonna have any use. So from main df we want to drop, and I'm going to show you what in place function do. In place equals to true now. We want to drop what columns. Oh, sorry, I don't columns CULUMNS. so columns equals to this employee id. okay, see, now it has 10 columns only. Earlier it was having 11, and see, no employee id is there. But if you just call it again now, main df, then it has employee id. So that's why we need to call in place equals to true, so that just to replace, or you can say remove them permanently. Now see, it has no employee id. So that's how you can do it. Now let's just go for some more numerical analysis, and then we're gonna go for the visualization. Okay, let's see group by method of department. Okay, like what I want to do is department wise we want to analyze the data. Okay, like for sales department, how many projects were given to sales, like whole sales person. Okay, all the employees belongs to sales department, how many number of projects they got in like whole in overall total. Okay, and overall average monthly hours employees of sales department used to work or worked in last 10-15 years. Okay, and how much time usually those sales department employees have served in the company in the years. Okay, so let's just see main df dot group by and group by function does same. It just grouped, like see sales might be having like 200 rows means I think employees belonging to sales might be 100-200. So just group by function just makes it total of everything. Okay, just see group by of department means it doesn't matter how many employees work under sales or support or IT, just make them in a group. Okay, dot mean, and we just want to find their mean. Okay, see it's raining outside here. Okay, departments of IT, number of projects they usually got. Okay, not mean first. Let's see the sum. Okay, like sum of everything. IT departments, all the employees, okay, got total number of projects 4683. Okay, every monthly hours they spend this much, time spent the company in 4 to 5 6 years on the like total number of employees belonging to IT. They spend the time spent in company, okay, in that particular company, total 4 to 6 years. Work accident total they did 164, left total 273 employee left. Okay, promotion last 5 years, like who got the more promotion? Sales. Okay, sales person belonging to sales got more. And satisfaction level, yes, they were more happy. I think last evolution this much. Let's find their mean, and this is like don't go for sum, like means don't just look at sum and just go over, just see the mean because it will actually show you the more correct way. So if you just look at the sum, look at the mean. So see which of the department employees were more satisfied. You can just see 62% management. Okay, this is why mean, because in sum you can just say yes, sales were more happy, but the number of employees, okay, that is also like if the number of employees in sales is low, then the chances are that their satisfaction level in sum will increase or decrease. Okay, promotion last 5 years they got 100 in management, yes, in management, where it is, in management they get 69, but in mean promotion last 5 years, okay, according to the number of employees, management got 10% almost, or I hope 10%, and sales got you can say less than 0.24%, and they got like 0.10. Okay, so I think number of employees in management is less or more, so that's why in some like see, in some you can just see sales was having more promotion, but because they were having more number of employees, and see how much they left, 1014, and management only 91 left. Okay, because see, number of employees also affects na. Okay, so that's how you can do some numerical analysis. And I think only 1 to 2 3 more, and then we can go for data visualization. And see here, left how much sales, 24% people left. Okay, and in management only 14% people left. So that's how you can just go for the mean. Okay. And let's see value counts. Yes, here you can see now. Here you can see the value counts. I should have go for here now, not here. All right. I should have go for here, main df from department dot value counts, how many people actually worked na. So value count, see, it's calculating. See, in sales 4140 the employees have worked, because if you go for the number, if you just go in the rows na, okay, so it is now counting how many times sales was, sales is there, means how many employees have worked. Okay, like in the, so it is now counting, and 4140 sales employee, total number of employees worked in sales 4140, and in management see only 630. So that's how employee number of employees also affects the sales, or sorry, affects the satisfaction level, or you can say data numerical analysis. And at last we just want to see main df, how many means value counts of left, value counts. So in total 14,999, sorry, 14,999. How many though, like not left? 11,428, and 3,571 left. Okay, 1 means left, 0 means not left. So here our numerical analysis got almost completed, and we have this one. Okay, you can see this one comes under visualization. Okay, but all right, after that, after 2 to 3 graphs, we're gonna prepare our data set for machine learning. Okay, means pre-processing of splitting the data into training and testing, and then predicting the model. Okay, so our numerical data analysis is complete, and let's move forward to have a graphical presentation of data. First of all, I'm gonna show you how to make this correlation matrix. Okay, and I'm gonna explain you. Then some just 2 to 3 bar graphs, and then this scatter pair plots. Okay, that's all. Then we're gonna go for data pre-processing. So right now, just a 2 to 3 or 4 data visualization. This is the second step, you can say. Okay, for any data science project, if you have the data, sorry for visualization, sorry for spelling mistake, whatever spelling of data visualization is. After importing the data, we did data numerical analysis, and we dropped whatever is not required. Okay, like this employee ID na, it was not required, and we imported CSV file, like second CSV file. So that's why we do data numerical analysis, just to see what is important, what is not, and through data visualization we visualize the data, okay, so that we can understand the data more better. So visualize, we're going to import two modules, matplotlib dot pyplot as plt. This is our first visualization tool, and second is import seaborn as sns. Okay, now first let's make correlation box, this one. Where is it? This one. Okay, let's make it. And first of all, I'm gonna make a function. Okay, just don't get confused, because this correlation box is might be little confusing, but other graphs are easy. Okay, other graphs are easy, but this one is little bit, only little bit tough. And I'm going to explain you code. Just let me write. Okay, xplt dot subplots, like this is kind of a subplot, and right now we are defining the figure size is equals to size by size, so whatever the size gonna be. Okay, so we are making a function x dot legend x equals to x dot mat show and correlation box it should show. Okay, first of all we defined a function, then for correlation box we defined like data frame dot correlation, and then of course the figure size, the subplot, like the and now color figure dot color bar gonna be cax. Okay, and what's gonna be the in the x-axis gonna be plt dot x text. Okay, if you just know the basics of matplotlib, then you can make it length of code dot columns. Oops. Columns, and core dot not color but columns. Rotation is equals to vertical, and at the last point plt dot, I think it's the same, right? Okay, so it's the same except for x is gonna be vertex, and range length and this much. Okay, it's done, and let me just call this function here only, plot core. And what's our data frame? Okay, what's our data frame? Main df. So what's the error right now? Such like no property fixed size. Okay, this is our subclass has no property fixed size. Okay, let's figure this out. Fig size. Okay, this is not subplot, this is subplots. Okay, now again an error. Text of the no rotation, but it's rotation. Okay, rotation. All right, now let's visualize this. Okay, like first of all we just defined a function to take data frame of this size, and then we call the correlation function with, if you just know the Python, sorry, matplotlib basic, then you can make it easily. We call figure and axis or with subplots like this, and then we just defined it like ax.legend is like for these labels, and then in x-axis we want like the columns. Okay, and in y ticks, like in x ticks, we wanted like columns, correlation of columns, and y ticks we wanted same. Okay, now let's visualize this. This one is like you can say higher intensity, and this one is lower intensity. So see, satisfaction level, just visualize this. Okay, see here, this is more darker. Okay, what is darker here? This two box, and satisfaction level, and above one is left. Okay, that means satisfaction level is the most important reason why somebody has left the company. Understood? Okay, understandable. Because of course, if any employee is not satisfied, then he will leave the company. Same here for left, like again same labels, so understandable. Then let's get it for like little more darker, little more lighter, you can say. And here I think this one, left, and left for work accident. Okay, left for one work accident, and left for, yes, work accident again, and satisfaction level with number of projects. Okay, and like if somebody is left for like most of the reason for leaving the company is satisfaction level, and the second most reason might be work accident, because according to this matrix, okay, according to the what data is telling us in the CSV file now. And what is not the reason to leave the company is number of projects, average monthly hours, yes, time spent in the company, same label. So don't get confused, because if there are like same labels, okay, left, it doesn't make any sense. So you can just leave it, of course, because it had to write now. So if you have the label same both sides, so just ignore them. Okay, but just see this satisfaction level, this side, this is more darker, and this left means satisfaction level is the main reason why somebody has left the company. Okay, now let's move forward for next graph, that is now just some bar graphs. Okay, and why you should make this kind of graphs in Seaborn. I'm gonna tell you why this kind of problem occurs. Okay, so you should make bar graph type of thing in Seaborn using Seaborn tool. But let's just still see plt.bar, but we are first gonna make it using matplotlib, and main.df is the file name in the x-axis, and from that we want to call left, means in the x-axis we want left columns of the data frame main.df, and height, like if you just press shift plus tab, okay, it will just suggest you in the Jupyter notebook, it will suggest you height. Okay, in Visual Studio Code it's control plus space. Okay, but here in Jupyter it's shift plus tab. HEI GST is equals to, if you again press tab, from main df I want what, just a satisfaction level, level. Yeah, it's drawing. Okay, and till then let me write for Seaborn till the work is going on. Seaborn, how we call bar graph is bar plot. Okay, and okay, it's running. In x-axis we just want what, if you just press shift plus tab, no, it's not working right now. Shift plus tab. Okay, all right, I don't know, it might be it's running, so it's not displaying. But if you but in Seaborn you need to write like this: Seaborn.barplot x equals to, next axis you want a left. Okay, and in y axis you want like see, in matplotlib it is height. Okay, y means height, but in seaborn it's just y. Okay, why you want this satisfaction level? I don't know why it's taking so much time. Okay, let me complete it and then I'm gonna show you. Okay, like I'm just gonna, and the data from which data frame, we have not called any data frame, no, it's from main df. Okay, let me keep it a little more above so you can just, okay, just see this. In matplotlib it's like left has in x-axis we want left. Okay, left has a value of 0 or 1. Okay, like just see, it doesn't make any sense. From 0.50 you have this. Okay, and from here you have, like from here I think it's 1. It's like division is 0.50. From here it is I think 0, from here it is I think 1. Okay, so see, it's not appealing that much. But in seaborn, okay, you have just 0 and 1 with colorful bar graphs. In 0, okay, like why somebody has not left the company, like in the past 10, 15, 20 years, left 0 means, and see, labels are already present. Okay, so why somebody has not left the company? Okay, like for 0 means not left and 1 means left, because their satisfaction level was above 60%. Okay, like almost 65% on an average. But all the people who left the company, their satisfaction level was like below 50%. Okay, you can even cross check it with this CSV file. Like there means not here actually, but here in data frame you can actually go to even just cross check it. Okay, you can actually cross check it. So satisfaction is like literally the main reason. Okay, so here that's how you can do data analysis. Let's import 2 more graphs. Okay, 2 more graphs, and this time it's SNS. From seaborn we want again bar plot. In X we want promotion. Now let's means let's go for another column. No, we want, like this time we want to analyze promotion last 5 years versus in y-axis we want satisfaction level. You can go for any column again, any numerical column, because see where it is. See, department and salary is a categorical data, not a numerical, so it cannot just you can just cannot make graphs of it unless and until you you convert it into numerical form, and I'm going to show you how to do it in data pre-processing last 5 years. And in Y we will just want this satisfaction level, and now just see first. Okay, oh sorry, data, I had to call data. From data, which data? Main df. Okay, okay, means promotion last 5 years you have just 0 and 1, means in 5 years some, like either if anyone, like see, nobody got I think promotion more than 1. Even if you go cross check it now, promotion here in this column, I don't think anybody got promotion more than 1. So it's 0 and 1. Okay, see, all the zeros are there. And I think only few people, let's see, is only few people had 1. Okay, but not more than 1 in last 5 years. So see, like if you just go through this now in promotion last 5 years, you will find many zeros. Okay, like many zeros, and very few 1. Okay, like see, in G column we have many zeros, but only few 1. Okay, like just see, we just got it over now where it went. So just see, I hope you just saw now where AC, very few 1. Okay, but we have many zeros. Then why 0 is showing less in promotion last 5 years and in 1 it is showing more, because here we have satisfaction level and it is getting confused. Okay, like how to show promotion last 5 years in x axis and satisfaction level in y axis, and just correctly show it. Like it has to show, you can say, because see, those who got promotion their satisfaction level on an average was about 65% almost. Okay, but those who did not got promoted, okay, their satisfaction level was 61% on an average. So this is showing this, that's all. So don't get confused. You just need to analyze the data like just by using some logics. Okay, you just cannot go, means just, I know what you're thinking, that there are many zeros, but if you just use logic now, then in y-axis you have satisfaction level, and those who did not got promoted, their satisfaction level is obviously low no? So that's why 0 is showing less here versus 1. Well, and I have one more thing for you, that is hui means color. Color should be left. Now you will see. See, now it's gonna make more sense. Promotion last 5 years, satisfaction level, and we have, according to the colors, blue is for those who left the company and one is for those, blue is the for who stayed in the company and one is for those who left the company. So in last 5 years, those who did not got promoted, okay, anytime, okay, and those who like literally did not got promoted anytime, okay, their satisfaction level was 0.65. Like see, those who stayed, why they stayed, even though they did not got promoted even for one time, because their satisfaction level is 65%. Okay, just see left, like see, for colors, according to colors, okay, 0 is for those who did not left, okay, blue color. So those who did not left means the blue color, their satisfaction level was 65% even though they did not got promoted, and those who left, okay, their satisfaction level was below 50%. So that's why, see, orange color, left for orange 1 means they left because they did not got promoted and their satisfaction level is like really low right now, okay, below 50%. Now those who got promoted, they did not left the company, okay, like this blue color, because their satisfaction level was like again 65%. But see, those who left the company, even though they got promoted, like see, even though they got promoted even for one time, but they left the company, okay, according to this left value, orange color, because their satisfaction level was again below 50%. Okay, I think they wanted more promotion. Okay, so let me just tell you in 1 minute again quickly. What we are seeing right now is promotion last 5 years, those who got nothing, their satisfaction level was still 0.65% almost, and blue color means they stayed in left. See, we have given color who is equals to left, means for blue color it's 0, means they did not left, they stayed in the company, okay. And those who left, like for one color, so for one we have given orange color, okay, their satisfaction level was 45%. And those who got promoted in the last 5 years, their satisfaction level was 65% almost, and they stayed. That's why, because why they stayed, their 65%, like their satisfaction level was 65%. And those who left, their satisfaction level was again still below 50%. Okay, even though they got promoted at least. Okay, I think they wanted more promotion. Now last, and that's how you do data analysis. And last, we just want the pair plot. It's gonna take little more time, but I'm just gonna pause after this till it loads. And if I just do this now and let it load, okay, I'm gonna pause this. Okay, so it is now loaded, but it's still not making so much sense because every color is same. Okay, like we just cannot visualize, like see, okay, those who left, like see, okay, those who left here in this column, for what reasons? Okay, like see, in x-axis we have left, and in y-axis we have like many things, or like satisfaction level. Okay, for satisfaction level, why they left, even though we can just see now, like this is 0, means they stayed, and according to satisfaction level in this column. Okay, this is the column of left, and this is the row of satisfaction level. Okay, because their satisfaction level was high. Okay, so that's why they stayed in the company. But those who left, okay, like this one, their satisfaction level was low. And even though in last evolution, those who left in the last evolution, like this is the current scenario of their satisfaction level, but last time when it was evaluated, whatever, their satisfaction level was pretty high because see, they did not left. Okay, and those who left, their satisfaction level was low, of course, but very few people left. Okay, but see, satisfaction level now, okay, large number of people left, okay, but last time only few left. Okay, just see, okay, and very much people stayed, and this time very few people stayed. Okay, as compared to last time. That's how you can do data analysis and show to your company what was the previous scenario, and what is present scenario. And that's how you can actually think about, like, oh, what wrong you are actually doing now. Okay, after data analysis, after data visualization, you can actually know we are doing something wrong. Okay, we are doing something wrong, and we're gonna find what you are doing wrong, but it's still not looking that much good because of colors. So sorry, means the color we're gonna give according to left, means there will be two colors. Let me just run and you will see, you will understand. Okay, so it is now loaded, and now it's making more sense because see if I okay, for left, like see, you can just see and just visualize it. Those who left, okay, in like, if I go for current scenario for satisfaction level right now, not last evolution but right now, okay, those who left, okay, they are having like now the blue color, and those who stayed, they are having the orange color. Like see, for one, sorry, those who left, okay, those who left, for one, like see, in left one, those who left, so they have now orange color, and those who stayed, they got blue color. Okay, right now according to their satisfaction level, okay, we are visualizing it. And last evolution, like not present scenario but at the last, okay, those who stayed are in blue color, and those who left are in orange color now. And we can just see and tell, okay, like see here, if I just want to know average monthly hours, what should I actually let you know is, see, again for like same, just come same left. Okay, next axis we have left, and in y we have number of projects. Okay, in blue, what we have, blue 0 means those who stayed in the company, and those who left has orange color. Okay, so those who stayed in the company has now like working in a less number of projects. Okay, just see, they were working in about only, just you can say 5, means of course 5 number of projects, and those who left were working more number of projects than those who stayed. Okay, you can just see and clearly visualize it. Okay, now let's take another column. Okay, what is colors is showing? For blue color, they stayed in the company, and for orange they left. Okay, blue color they stayed in the company, and orange they left. Okay, so if I just take satisfaction level with average monthly hours now. Okay, so this box. Okay, this box. Satisfaction level with average monthly hours. So next axis we have average monthly hours and satisfaction on this one. Okay, so those who were working 300 hours average monthly now, see 300 hours, 100 to 300, and if you just see, this comes beyond 300. Okay, this was the 300 line, this is, and this comes under, like, some people were working beyond 300. Okay, and their satisfaction level was below 20%. See, below 20% now. Okay, and they left because one is showing here left, means, sorry, orange is showing here left. Okay, but just see here. Okay, one more thing, some people who were working less than 200 hours, even though almost 100 monthly hours, only 100 monthly hours. Okay, just see here, even though their satisfaction level was below 20%, but they did not left. Okay, they stayed in the company. And same here, if you just go here in this area, some people who were working 100 hours monthly, okay, their satisfaction level was like almost 100%. Okay, so this can differ from person to person. Okay, this actually differs from person to person. Okay, so our data visualization is completed, and let's move forward for data pre-processing. And in data pre-processing we have two things. Before data splitting into training and testing, we have we need to do label encoding. Okay, this is, I'm gonna just tell you, and we're gonna do one more thing here before, like, after training test split. Now we have one more thing to do, that is standard scaler. Okay, like, to scale down all this data into a particular range. I'm going to tell you what I'm saying. Be with me. Okay, but our first algorithm is decision tree. Now our first algorithm is decision tree, and in decision tree it's just like yes or no. So we don't need to get bother about what is the size of, like, what is the magnitude of every column. Okay, because this is a yes or no. I'm going to explain what I'm saying, but in first of all, let's first do data pre-processing, then I'm going to explain what I'm saying. Actually, data pre-processing, and first of all, we have, see, first of all we need to do label encoding. Now what is label encoding is, now see, the model cannot take data into, like, in wordings, you can say in strings. This is string now, this is integer. Okay, these are integers. Okay, 157 and all, but this is string. Sales, medium, low, support, IT, management. Okay, model means computer does not know what the sales mean, what the IT means. Okay, model just know numerical data. So we need to convert these, all the terms, all the strings, into numerical data. Okay, even though salary is low, so low it might be 0, and for medium it might be 1, and for high salary it might be 2. Okay, let's see. Okay, but so I hope you understand that we need to convert the labeled data into a numerical form. That's all. Okay, all the things are in numerical form except this department and salary. So we have to do this. So y, let me name it y, main df. What we need is just two columns, department and salary. See, see. Okay, this two only we need to convert. Okay, from sklearn dot pre-processing import label encoder and le equals to label encoder. Okay, L is equals to label. That's how we call label encoder. Okay, and we are storing it in a name variable named le. Now y is equals to label encoder dot fit only fit transform what we want to transform is you can say. Now don't get confused here that I stored y like I stored department salary in y. You can just like cut it or leave it. Alright, let's name it k. There are some people might get confused. So transform, what we want to transform is df salary. Okay, means we want to transform salary, like that is low, medium, high, into a numerical form, and we want to store that numerical form in k variable. Okay, so let's call this, and let's, if I just call k now, see it has now converted into 1, 2 and of course 0 also. But we need to see for 0. I hope, like earlier I did label encoding. For low it gave 1. Yes, for I think for medium it gave 1. It gave 1. For high it gave 0, and for low it gave 2, I think. Okay, so let's see what it actually gave. So we're gonna make another column in df. Okay, like in main df we have this much of column. Okay, this much of column, so we don't need this 2 column now. So we're gonna make another column. How we gonna make is, how can we actually make it, main df like this, new salary or salary numerical num. Okay, and what value we want to store is k in that. Okay, like if I just give it like this, now it will say like key error salary number, because it's like we are calling salary number which is actually not there now. So we need to make it like we are making a new column and we are storing a number. And now let's see, if I just call main df, see we have salary number. Now for low it gave 1. Okay, for medium it gave 2, and most probably for high it gave, of course, 0. Okay, but still if you want to cross check, then you can just simply do main df. Okay, from main df dot loc. Loc is for like calling any columns with their names. If you want to call any column with their index, you can use iloc. Okay, log and which column you want to call, you can say salary equals to high, means so the only those rows which like for high salary. Okay, you just want to see rows for when the salary is only high. This is only showing low and medium rows. Okay, but we want to see high, so see, okay, it is showing only those columns which has salary high, and it gave in the salary number, yes, it gave 0. Okay, so officially we have for low we have 1. Okay, for low. For medium we have 2, and for, of course, for high we have 0. Okay, and after this we're gonna drop salary. Okay, but just let's drop it now permanently, because we don't need salary right now because work is done. We just need salary num, means salary number drop. That's how you drop anything. What we don't want to drop, salary column from axis 1 means from from columns. Okay, x is equals to 0 means from rows. Okay, but x is equals to 1 means from columns. And like see, because salary is in columns, no, in columns. Okay, not in rows. And in place equals to true to remove it permanently. Okay, otherwise it will not remove it permanently. So just see, now salary is not there. Okay, salary is not there. Now same we gonna need for department. So I'm just gonna copy this one, not full, but this one only, and we're gonna store not K, but let's store Z, no? And department, if I transform, and if I just call J, it has like from 0 to 8, it might be. Okay, but let's make another column like this. If I just copy this one, and is equals to Z, and here what, department number. Department now means we are making another column of department, and let's just see what it's looking. We have department which we need to drop it, and department number means sales it has given 7, for support it has given 8. Let's see for HR what it has given. Okay, you can actually cross check it. Where was it? Yes, like this again. Department. We just want to call HR. For HR column, or HR rows in columns of department, it has given 3. Okay, and let's see for IT. I think I'm writing right. Yes, for IT department, it has given number 0. Okay, so that's how you can just cross check it. And now let's draw department. Department and main DF. Now let's see, salary is gone, department is gone, and up, and in place of that we have now salary num and department num, and with 10 columns and 1 means 14,999 rows. Now our work is almost done. We just need to split the data, okay, in training and testing. So how do we actually do it? See, this is our main data frame. Okay, except this is gonna be like, this is our target variable, no? Like what was the outcome of last 5 years, 10 years, 15 years, and based on what? Based on this till here, from till here, and from till here, based on this parameters, that was our outcomes. Okay, that was our outcomes, whether the person or the employees working in this number of, like if their situation were in this parameter, they left it or not. Okay, so based on this we can predict the future, because whatever has happened in the past, okay, because these are the parameters, right? And if any employee is coming under the parameter, so we can now predict that according to past, even this employee will leave the company or not. Okay, so we can just go and tell our boss that, hey, this person, employee number randomly, employee this is working in this parameter. Okay, is under this parameter, means he got no promotion, his satisfaction level is low, then according to previous experiences he will actually leave the company, because the person who were working in the same parameters, okay, they also left. So this gonna be our this gonna be our y, and apart from this, all the other thing gonna be our x. So x equals to main df, all the features of main df except this. So we're gonna drop it, means not drop from main df, but we are storing it in x now. So except what? Except only left. Okay, left, only left, and from x is equals to 1, means from columns. Now see, if you just see now x, we don't have left column, but if you call main df again, now if you just call main df again, see, you have left still, okay, because we stored everything in the x except we dropped left. Okay, now x has this, and y gonna be our like target variable. So from main df again, we want left column, left. So now see, if I just y, see, dot value counts, we have like 0, like those who did not left 11,422, 28, and those who left 3,571. And if I go for the size, 14,999. okay, and see, size of main df is 10 columns, but as we drop the left now, so size of x is now only 9 columns, means this much rows and 9 columns. Okay, shape, you can say shape, okay, and not size but shape of the main df was this much columns into 10, this much rows into 10 columns, and shape of x is this much rows and with 9 columns only. So let's split x and y into training and testing. And what does this means is, we're gonna split x and y for 70% of training. Okay, means you can say till, you can say like 11,000, okay, almost 11,000 rows for training, and rest of the 30% for testing. Okay, so that we can test if our model has predicted, or you can say if model got trained correctly or not. Okay, so we're gonna give 70% of the thing to training, and 30% we're gonna keep it for testing. So sorry, sklearn dot model selection, I'm gonna import train test split, and alright, now x train, like we need x train, like for 70% of the training data we're gonna give here, 30% of training data gonna be here. And labels, what are the labels? Left is the label. So y train means, just give me 1 minute, test. So this means that 70% of training data gonna be in the x train with respect to its labels. Okay, like if that person has left or not, means 1 or 0, and 30% gonna be in the x test, means, and with respect to their label data. So we are naming it y test. Okay, so we have two variables actually, x and y, and 70% of x gonna be in x train with respect to its label y, means in like y train. Okay, with x train data, the label is y train. Okay, and 30% of x gonna be in x test, okay, with respect to its label, and we are naming it y test. Okay, so train test split, what? Split x, okay, with respect to its labels. And what is the test size? Means, of course, how much you want to give to test is 0.3, means 30%. Okay, and shift plus tab, I think we are having some more features. think so. No, we have not run that now. Alright. So give me 1 minute, okay? We'll give on this one. Alright. So if I run this, so see, we have splitted X 70% in X train and 30% X test with respect to its label, and means 70% of labels, okay, with respect to X. So we are naming it Y train, and for testing Y test, okay. If I now just see train, see, earlier X was having 14,499 columns, but almost like 10,500 10,499 rows is now for training, okay, means 70% of 14,999, okay. What is 70%? 10,499, and now it is for training, okay, named as X train, okay. And columns gonna be same, of course, because these are the features, no, okay, these are the parameters and these are the features. So 70% of features gonna be in X train, and for X test you will see just 4,500 rows, okay, means in this much features we gonna test, okay. Like we gonna, after training we gonna test on 4,500 rows, okay, that how much it predicted correctly based on the actual data, okay. Like I'm gonna explain you. And Y train is this much. If you go for the size, earlier the size was 14,999. now the Y label has size 10,499 with respect to S train, even its rows was this much only, and Y test it's gonna be of course 4,500, okay. So after this data pre-processing is done, and it's time to call our decision tree classifier, okay. Now let's predict our model, and I'm going to show you what I'm doing is model classification, and first one is gonna be decision tree, and one more thing is here is standard scalar, means I'm gonna explain you, but let me first explain you what is decision tree, okay. So our first machine learning model is decision tree, and let me remind you again, because in data pre-processing we skipped standard scalar, because this is we gonna do not in decision tree, because in decision tree it is not required. I'm going to explain you what is this, okay. If somebody don't know, it comes under data pre-processing to scaled down data, okay, means see, difference between 157 and 3 is huge, okay, it's super huge. So it needs to come under a particular range, okay, like between 0 and 1 you can say, so that we can actually work on this data, okay. But in decision tree we don't need to do standard scalar, because in decision tree, like decision tree is super easy. It's just like yes or no. It's just like yes or no. See, okay, see, if the age is less than 30, okay, and if he eats lots of pizzas, okay, if age is less than 30, yes. If he eats lots of pizza, yes, then he is unfit. No, then means he is fit. And if age is less than 30, no, means age is more than 30. Exercise in the morning, yes, he is fit. No, unfit. So decision tree just analyze the data and just predict, okay, just make its branch, okay, like this is a kind of tree, this is kind of tree, okay, this is kind of tree, student income, no, yes. Okay, it just makes the tree, it just analyze the data, okay, learn the parameters, and just it don't need to find any distance between anything. Now I'm going to explain you what I'm saying. So we don't need to scale down data, it just analyze the patterns, it just analyze the parameters, okay, and then it just say yes or no. Okay, if it just predict according to the parameters. Okay, it just analyze the parameters and it just say that if that parameters, if you are coming under a particular parameter, no, then do this, and if you are coming under a particular parameter, yes, then do this. Or another question, like if you are coming under that parameter, yes, then if you are coming under another parameter like see income, if your income is high, then do this, no, medium, then do this. Okay, so it just analyze the pattern and just say yes or no. That's all. That's all. See, decision tree is super that simple. How do we call that? From sklearn sklearn dot tree. Okay, dot tree. I'm going to import decision tree. That's how we just import it. decision tree classifier. It also is used for regression. So I'm just gonna name it DT. Decision tree we can use for classification, like between yes or no, and for regression also. Okay, for like time series thing. Well, how to call decision tree classifier? First we imported it, and now that's how you name it. So decision tree classifier, I have named it DT. Okay, so DT dot fit. Some people name it model, but we are gonna use multiple models here. So let's just name it according to their according to their nickname. So DT for decision tree dot fit. Fit means we are now giving the data to train. Fit, just do that. Okay, it just trains, means to train the model you just need to do simple thing. You just need to call fit function from decision tree or calling fit function, and what you want to train, x train. Okay, that's 70% of the data with respect to its labels. Y train. Training is completed. Simple. Yes, really. If you just call fit model now, you just need to give two parameters, training model and its label. Time for testing. Okay, time for testing. And we have trained the model now. We have trained this model. Okay, now DT has been trained, decision tree has been trained. Okay, you can see this much of thing. And I want you to go through its mathematics, like what is Gini, okay, what is minimum impurity decrease, what is minimum samples, okay, and all. So, but now that's prediction. Okay, prediction of, now we're gonna predict it on the rest 30% of data. Prediction of DT, decision tree dot predict. Okay, that's how you call predict. First to train the model. Okay, first you trained this DT, and now you are predicting it. Okay, first you trained it using fit function. Now you are predicting it, and you are storing that score in this. Okay, predict, what you want to predict is x test. Okay, and see, now if you just call this prediction DT, what is its size? I hope I can. Okay, why it is showing like this? Okay, like dot dot dot, because its size is huge, no? Because of course size is huge, 4500. Okay, so we cannot just see all the labels 0 or 1. Well, how to know if decision tree has predicted on x text correctly or not. Okay, with how much accuracy is predicted correctly. Okay, so simple. If you like, just call one more thing, one more column, from sklearn dot matrix. I'm going to import accuracy score. Okay, run this, and accuracy score compared to y test means, okay, labels of x test means this, okay, labels of x test, what was that, y test, okay, see, labels of x test was y test, okay. So we're gonna compare the actual data. This is the actual data, now this is the actual data after splitting, now okay, after splitting we gave training and testing. X-train is for training, and see, this was like X test, no? And what was its outcome? This one means left. How, if like, what was the outcome of this much features? Like for 4243 person is whoever worked on this like employee number you can say or whatever, but whoever worked on these parameters, that person stayed. See, 4243 4243 6978 that also stayed, but 1831 indexed, those person who worked on this, okay, they left the company, okay. So this is the actual data, this one is the actual data. So now we trained our model in X train, and now we predicted on X test, okay, like if person, like we predicted after giving this much parameters, okay, and we are now predicting if that person is will actually you can say will actually leave the company or not, okay, based on this actual data, this previous data, okay. So we just gonna compare y test with prediction dt. See, the accuracy score 97% if you just write like this now. So means we predicted 90 with 97% of accuracy. See, okay, means this was the actual data, na? Means y test was the actual data of like what happened in the last 10, 50 years you can say, okay, and last 10, 20, 50 years, and we gave, after training in X train, we gave our model to test on these parameters, okay, these parameters, like if any employee in future is under this parameter, okay, like if he has done if he will do 4 number projects, if he is spending 175 average monthly hours, and he has spent 2 years in the company, and so on. So if now predicted that he will leave it or not, okay. So last time the person who was in same condition left the company. So the person who will actually work in the company, and if he comes in this condition, okay, in this condition, then based on the previous data, he will also leave, okay. So now we can actually go to our boss and tell that, hey, one of our employee is in this condition, so chances are that he will leave the company because the previous person also left, okay. So we compared y test, that is the actual data, okay, like what happened in past with what's going to happen in the future according to past, okay. So its chances are that if I just see 97% means, see, first index is 0, okay, means 4243, the person who was working in 4243 like he actually stayed in the company, okay, and we predicted it, like if any of future employee comes under that condition, then he will leave it or not, and it is saying that he will not leave, okay. Same again for the second one, okay, for the second one 6978, that person also stayed, and our dysentery classifier is also showing that he stayed. But here, see, in 1831, okay, if any like in past employee worked under this condition and he left the company, okay, but now we gave our dysentery classifier to predict that if any person actually work in the same condition of like previous employee who worked in 1831 condition, index number this much, okay, then he will leave or not, okay. So our model tell that he will not leave, okay. See 0, but actual data is 1, okay. So there is a wrong answer, you can say, or there is a wrong kind of prediction, because actually our person left, okay, but our model is saying he will not leave the company, okay. So that's why error. Now there is a error, okay, there is a error. So how much is the error total? How much is the misclassification, you can say? You can say almost 3%. Like see, 97% the accuracy means how much is the loss? How much is the error? 3%. Okay. So our model predicted the outcomes with 97% of accuracy, means 97th times, means for 97% time the model actually actually told the correct outcome, but for like 3% the model misclassified, okay. Now let's give a custom data, okay, like let's give a custom data and like see if just give the custom data which was not in the X test also, most probably, and then we're gonna see what is the most important factor which will lead any employee to leave, okay. So let's give the custom data. XDT or custom DT, you can say, like if anybody custom DT or custom data, and how much is the columns? 9 columns now, okay. 9 columns. So let's just give custom data. I'm just gonna give randomly, okay. Not randomly actually, but X test for 0th index. Sorry, not 0th index, but X train. Let me call this. Sin 3 6 3 5. No, not why. Whoa, what it is showing? Alright, leave it. Well, number of projects, let's say I'm just gonna give any custom input, like even if it is not in extrain or extra. Let's say number of projects I do 10, okay, 10. Average monthly hours I spent 500. The time spent I company in 10 years. Work accident I actually did 6, not 0 or 1, but 6. Promotion last 5 years I got 4 promotion, okay. Now model gonna go blast. Satisfaction level, I have satisfaction level, I don't know, let's say 90%, or it's like 0.90. And last evaluation I was having 0.89. Salary in numerical order means 2 was for what? Guys, do you remember? I actually don't remember right now. High it was low, and thank God I did not ran this model, okay, ran this block. Salary, okay, for low we have 1, for medium we have 2, okay. Now let's see, my salary is high, okay, high, and department number anything like 8, I don't know what is it. Let's see, this is your custom data, okay, and let's predict now. How to predict? DT dot predict again. Predict what? See, custom DT. It will show an error. What? See, expected 2D array got 1D arranged it. So means any kind of custom data you want to give, no? Means see, your data even though your X test is in 2D array, okay. I don't want to explain about this much because beginners will actually get confused. But understand is that for predict, like for training we give 2D array, na? So for testing also we need to give 2D array. So what is array? What is like 1D array or just a list? Okay, but what is 2D array? List under a list. Okay, means list under a list. And what is 3D array? This much. Okay, and if I just see found array with 3 dimension, estimator accepted less than 2. Okay, so this much. And see array 0 means I'm not gonna leave. Okay, and one more thing here, if I just give less input now, so see it will show an error. One more, that number of features, the model must match the input. So what was the input of training? Model and features is 9, means the input I gave like for training now this much. Of course for training xtrain, where it is like for xtrain and xtrain is same, so 9 columns. And now after deleting it, I have given 8 columns now. So it will show you model and feature is 9 and input and features is 10, means of course is 8, or like just don't get confused if I am writing it. But you need to give 9 inputs, because for training you give 9 inputs. Okay, 1 2 3 4 5 6 7 8 9. Okay, if you just remove any of this now, any of this, then it will show you. Or if you just remove one more now, it will go, you know, there. See, number of features of the model must match the input. Model and features 9, and the input and features I'm actually giving is 7 to predict. So that's why. So let's 0. The better way you can write, like just a better way you can write. Then I'm going to show you what is the most important feature that actually led, like why, like that satisfaction level is most important, but I'm going to show you how to actually find the most important one using decision tree. Like decision tree will actually tell you what was the most important feature, like what was the most important parameter decision tree find among this. Okay, so that any employee is like, why any employee is leaving the company. Well, I'm going to show you how to write this one in a much better way. Category is equals to say for 0th, means for 0 I'm staying now, employee will stay. Okay, and employee will leave. And this one was like, let me just first run this. It is showing in array now, so you can write like this to show it in just a integer. See, if I just press int, see 0, array is gone 0. So how to write it in a much better way? It's just like if I just write now category and indexed. So whatever gonna be the outcome, okay, if it is 0, then it will show employee will stay, and if it is 1, then it will show employee will leave. Because see, from category we are calling the index number. Okay, like this. So if the index is 0, so from category it will print, like see, if I just print the category now, it will print like this. But we want to print only that thing. Okay, this is the first 0th index and this is the 1st index. Okay, just print that index which comes like this. Okay, like if it comes 0, then it will print this. Okay, that's employee will stay. And if any outcomes, like see, I don't know, let me try to make it 0. Last promotion last 5 years, 0 1 2 0 1 2 3 9 0 1 2 3 4 5 6 7 8 or 9. It's like from 1 now. 1 2 3 4 5 1 2 3 4 5. Not if I not getting, not 4, but if I'm not getting any promotion in last 5 years, oh, I'm still showing 0 means I'm still gonna stay in the company. I don't know how, but alright. Average monthly hours, number of projects not 10, but I just gave 1 now. Oh, let's see what we are doing wrong. I don't know. My salary is high, Anna. Let me make it low. Means for 1, I think it was low, no? What? Really? Really? 10 now. I have spent in the company 3. So, okay, now it's 1. It's okay. Now finally I'm gonna leave. And if I just do, then employee will leave. Okay. It is called 1th index of category. That is this one. Okay. Now let's see what is the most important feature which, like, according to decision tree. So dt dot feature importance, it will show in array form. Okay, in array form. Like this. Let me write it in a much better way. Okay, much better way. Feature importance, like, let me name one. I see this one is like this, no? This dash, that's like, this is the function in dt to call the most important, and let me write it in a much better way. dt dot data frame, we are making a like a data frame to show which is the most important feature. dt dot feature importance to show the most important features like a data frame. And see, first let's go step by step. See, this is showing like this. Okay, but you don't know, you just don't know, na? Like what this 0 is showing, 1 is showing, 2 is showing. So let's make it more visualizable. Index, what's gonna be the index? X train, like whatever is in the X train or X test, X, okay, train dot columns. So columns, okay, and in columns should be filled like with this like this importance, okay, and short values, importance dot not here, dot short values in ascending order. Okay, short values or like short values of this importance. Okay, importance in ascending order. Ascending is equals to true, or false means we want in descending order. Let's see if I'm not doing anything. Okay, see, so we called, like, we named a variable feature importance, and we called, like, we made a data frame. So pd dot data frame of of just a importance feature of decision tree. Okay, like this is a indexed, we gave like a X train, like, see, this is the columns of X, no? Means even if you write X, then it's completely fine, but in X we have left columns. Okay, so in X train or X test, you are calling, like, you are naming your index. First it was 0, 1, 2, 3, no? So to name the index, you called the columns of X train, or you can call from X test. Okay, now columns is equals to this columns. This was the row, no? This was the row, and now columns you want to give importance. That means the name importance. Okay, even if I write Ashish, then sort values. Sort values means sort the value of the column importance. Okay, in descending order, means ascending is equals to false. So this is the most important feature. Even we saw this in the this one, no? This what do you say? In what do we say actually? Yeah, in correlation matrix. Okay, even we saw a satisfaction level left, which was the most darker. Okay, what was the most darker? This one. Okay, so satisfaction level is the main reason why somebody is leaving the company, and our decision tree has also shown us like satisfaction level is the most important thing why somebody is leaving the company or not. Okay, simple. So our decision tree model is completed. We trained and we test with 97 accuracy. We found like 97% accuracy, and then we predicted on the custom input, like if somebody is working in insane condition. Insane means a mad condition. Okay, then what gonna be the outcome, and then the feature importance, like most important feature. Now let's go for the our next model. Okay, so let's move to our second ML model, that is KNN, that is K nearest neighbor, and K nearest neighbor is very easy algorithm of machine learning. Let me just explain you like quickly. Okay, where it is. Okay, see, just a quick you can say explanation, and I want you to go through its mathematics, like what is the mathematics behind it. Okay, but here is just a quick explanation. So you have given input to predict, okay, which class does this star belongs. Okay, class A means yellow color, and class B is of violet color or purple color, you can say. Okay, now you want to find out, like, just for an imagine. Now I know many beginners are confused, like how does a star belongs to a class of circles. But just for an example, okay, if you just want to predict like which class does this star belongs, okay, this circle of yellow colors or this circle of purple colors, okay, this star. So what you can do is, now you can just apply the KNN model. K nearest neighbor means nearest neighbor. Okay, what you are able to understand is like, see, this input, okay, will calculate its nearest data points. Okay, and like, see, if you just give the like KNN, and what is K? Number of neighbors you want to find or number of neighbors you want to calculate. If you give K equals to 3, okay, so this point will calculate the nearest neighbor, like it will find the 3 nearest neighbor. Okay, it will just calculate the distance of its 3 nearest neighbor, and among all these data points, among all these data points, which are those 3 nearest neighbors? 1, 2, 3. Okay, so these 3 are nearest neighbors to these data points, and so which are in majority, purple or yellow? In these 3, purple, of course. So this star belongs to purple class. Okay, now if you give K equals to 6, now this star, okay, this star will look for the 6 most nearest neighbors. Okay, 6 most nearest data points, and among all these nearest data points, which are those 6 nearest data point? See, 1, 2, 3, 4, 5, 6. Okay, this might be the 7th if you give K equals to 7, and if you give K equals to 8, then 7, 8 also. But I will actually tell you how to know what input to give, like how to know if you should give K equals to 1, 2, 3, 4, 17, 18, 20, 25, okay, 50, 100. I will actually tell you how to know like which value of K is actually best to find the class of star accurately. Okay, but if you give K equals to 6 now, so it will just look for the 6, like those 6 nearest data points, and now which are in majority, this yellow. Okay, these are 4 and these are 2, so this star belongs to this yellow class, means class A. So I will actually tell you how to know like, of course, if you just give K equals to 3, so this star belongs to purple. If you give K equals to 6, then this star belongs to yellow color. So how do you know which like how what should be the value of k? I will tell you. Okay, so let's just start decoding. And now one more thing here. We need to do pre-processing of data again. Okay, like here we did now label encoding. Where we did actually? Here we did data processing of. In data pre-processing, we just like pre-processed the data, like we did label encoding. Okay, now one more thing we need to do. In decision tree, no need of scaling down data. Means see, in decision tree, it's just like it just analyze the data and it just say that it's like yes or no, true or false. Okay, it just analyze the data and it's just like yes or no. But in KNN, na, it actually need to calculate the distance. Okay, it actually need to calculate the distance. So here comes the another pre-processing part. Okay, that is called standard scaler. Okay, like standard what do you say, standard scaler, or of course and it actually do what? Standard deviation of data. Okay, it just do what? Standard deviation of data. Now what does this mean is, like for an example, see, this is 2. Okay, remember one thing, in KNN we need to calculate the distance. Okay, we need to find the nearest neighbor. Okay, so that's why we need to calculate the distance. So see, for this feature, number of projects, the maximum value is 7. Okay, or the minimum whatever you say, but see the difference. Even in the 0th index, this is 2, but see the average monthly hours 157. So just understand that difference is very huge here. Okay, and in some cases, like if you are working with the data which have features like centimeters, millimeters, or millimeters, centimeters, meters, kilometers, and miles. So just understand the difference between miles and millimeters. The difference is super huge. Okay, so how you can even calculate the distance if one of your feature is in millimeter and another is in miles? No, so of course, because the millimeter one will be in a very short range. Okay, and the miles one will be like you can say 10 kilometers away. Like if this is a millimeter, like if its magnitude is in millimeter. Okay, so this comes like this is very nearest to this input data. Okay, which we want to predict. And for example, if this feature its magnitude is in miles. Okay, so this will be like somewhere here. Okay, so of course, how do you even gonna calculate the distance? Okay, if some feature is in millimeter and some feature is in miles, so it's impossible to calculate and it's so impossible to find the accurate result. So that's why we need to scale down every feature data into a particular range. Means if someone is in millimeter and another one is here in miles, okay, then we need to scale down this millimeter also and this miles data also to be in a particular range, so that this can calculate the distance and this can predict the accurate result. Okay, like if a feature is in miles, okay, so and the another one is in millimeter, so they will get standard deviate. Okay, or you can say their standard deviation will be done. Okay, their standard deviation will be done, and those two feature will be in a particular range. Okay, will be here in a particular range. Okay, their values will not, like their meaning will not change, but their magnitude will be changed. Okay, they like if it is in miles, so it will come under in a range of 0 to 1, you can say, for an example. Okay, after standard deviation it will actually come under 0 to 1, just one example. And even though millimeters 1 will also get standard deviated, you can say. Okay, so that there should be no difference between a millimeter 1 and a miles 1. Okay, their meaning is different, because this feature is different and this feature is different, but their magnitude will be in a particular range, and that will be easy to calculate and easy to find the accuracy, or you can say easy to find the accurate class of the star. Okay, so that's what standard scaler does. Standard scaler will scale down this 2 and 157 in a particular range. See, the difference is huge, 157 and 0. Okay, and even like 0.38, and another feature is in 157. Okay, so the difference is huge. Difference is very huge. Okay, even though we are calculating the, like, see, if one feature is in 2 and another was in 157, so difference is huge. So this and this needs to be a particular range, like simply like this here. Okay, simply like this here. But if like this is a scaled down data. Okay, if we actually plot this now in 157, this should be here, somewhere here. Okay, so after scaling down, they are all in a particular range, here to here. Okay, so now it's easy to calculate, like it has calculated now, so now it's easy to calculate. Okay, like because this feature and this feature are in a particular range. Okay, so that's all about standard scaler. We just need to scale down data, like all the features, into a particular range. Okay, now KNN and data pre-processing of KNN. Okay, in again I'm saying in decision tree we don't need to do this, because decision tree just analyze the data and just say yes or no. Okay, it don't need to calculate the distance. Like in KNN we need to calculate the distance now. In decision tree we just need to analyze the data and we just need to say yes or no. Okay, data pre-processing of KNN. Okay, now how to do standard scaler? Let me tell you. SC is equals to stand and not and I first let me just call now. Wait, okay. From sklearn dot pre-processing import standard scaler. Okay, from scaler pre-processing import standard scaler, and standard scaler SC, we are storing this in a SC. Like what I'm doing is here, wait, I'm gonna explain you. Okay, I'm gonna explain you what I'm doing. Just let me write. Okay, we are calling standard scaler and storing it in a SC. Now what I think I should do for whole X. I don't know. Okay, alright. We know that this is our X train. Let me just call this. X train is not. Oh, I started it again now. Okay, so let me just run this quickly. Okay, so here is our X train, and why I just wanted to show you is because see, SC is equals to means standard scaler dot fit X train. What does this dot fit X train means? Is to do standard deviation, okay, of X train and X test. We will need to do like for whole X data, okay, for whole training data, and to predict on that, we need to do it on testing data also. Okay, like see, you're gonna train on the standard deviated data na. So to predict, okay, so to predict you actually need to convert the test data into standard deviated data. Okay, so what we're doing is here is we are just calling standard scalar dot fit extend means dot fit extend means this will first analyze the pattern of X train. Okay, this will first actually analyze the pattern of X train, and what is our X train is this. Okay, and then it will transform X train and X test according to the X train. Yes, after analyzing the pattern it will, like, let me just name a variable X train std. Okay, means X train standard deviated, you can say. Okay, now after analyzing the pattern of X train, we will transform that X train dot trans, what tab is now not working, transform tab button, I don't know why, transform X train. Okay, now transform X train and store this in X train std. Okay, and transform same with X test also. We are naming std and just gonna now transform X test also. Means after analyzing X train dot fit X train means standard scalar dot fit X train means analyze the patterns of X train and then transform X train according to that, and same transform X test according to that. Okay, now see your X train is this na. Your X train is this. Now if you call X train std na, X train std, it has now become this. Now see the difference. This one is the first or 0th index, you can say, or whatever it is. Okay, 7076 index. 3, the difference between 3, 200 and 210 and 2 and 0. It has reduced to, like, see, minus 0.64, 0.18. So see, it was 210 and now it has become 0.183. Meaning is same. Means computer gonna take it as, you can say, into a same meaning. Means I hope you are, just don't get confused, but just a values are now changed. Values has changed, means they have scaled down. Okay, this 210 has scaled down into this data. Okay, and this was 2, and of course dot means all the remaining features, and then this one. So this was the first index. Okay, or first, or whatever its real index is, what is 7076. Okay, and dot means all, and see 8 has become this. Okay, so see, they have all come, see, from minus 0.64 to, like, see 0.18, minus 1.03. so they are all under from minus 0 or minus 1 to 1. Okay, so they have scaled down they have scaled down, like, all the features has been now scaled down into a particular range of, you can say, minus 1 to 1. Okay, all the features has been now scaled down into a particular range of minus 0 point to 1 point. Okay, like 1 point. Now it's easy to calculate. The distance, because earlier the difference was huge. Earlier the difference from, like, 0. Okay, why it's not working? Earlier the difference between 0 and 210 was huge, but now they have become in a particular range of, like, earlier the difference between 0 and 210 here was huge, but now they've all scaled down in a particular range of minus 1 to 1. Means now we can easily calculate their distance. Okay, so they scaled down, and if you just look at the X test, earlier it was this, no? Now std. See, why we needed to convert X test also? Because if you're training it on scaled data, then you need to predict it on scaled data. Otherwise, you can say, of course, because you have scaled, you have trained it on lower data, means in a very short range, and if you just give high range, or you can say high numbers to predict, it will not give accurate result. So let's call k nearest neighbor. Let's just call k nearest neighbor from scalar dot n neighbors, only neighbors, import k nearest classifier. Okay, and we are storing it in knn. Okay, k near k classifier. Now here is the fun part of n neighbors, to choose n neighbors. Okay, like n neighbors mean choosing k. K is equals to 3 or 6, or how much should we give n neighbors? How much should be the k value? N neighbors means k. Okay, 3. Let's just say 3, and later we will gonna know how to choose the value of k. Okay, just be with me. knn dot fit. How to train? Just call fit function x and xtrain std. Okay, train it on standard data with respect to y train, and training is finished. And let's predict now. Prediction, not dt, but we're gonna name it knn. Knn dot predict, and predict on what? On what? Seriously, in x test std. Okay, just predicting on x standard data, and let's just know how much accuracy it got. Accuracy score, accuracy knn. Let me just write knn is equals to accuracy score to find the y test. Okay, how much is scored, like see, on a comparison of y test, this is the actual data. This one is the actual data, and this is the predicted one. Okay, this one we predicted on x test std, and this one is the actual label of x test. X test std. So we just gonna compare how much it predicted correctly. Okay, and we're gonna compare it with y test. Okay, like how much its answers are matching with y test. That is the predicted label. 100 y, because see, accuracy knn 95%. Why 100? Because of course 0.95, so that's why. In decision tree we were having 97% accuracy. Means if I just call prediction knn and now if I call y test, it has a difference. Like see, 0th 0 correct, 0 0 correct, 1 1 correct, but there might be some misclassification in prediction knn. Okay, means this one is the actual data. Okay, this one was like actual data of 3958, and for 3958 means let me put here. Okay, x, let me just actually write for 3958. Okay, the actual data, actual label of like employee has stayed in the company. 0 means the employee stayed in the company. Okay, and it predicted correctly. Okay, if you give test on these parameters, okay, 39 in the index of 3958, to predict if employee will leave it or not, then it predicted correctly. Okay, he will not leave. Okay, like just compared. Okay, we are just comparing the data, but there are some misclassification happened. That's why accuracy is not 100% but 95.75%. Now let's see if you just give do k and n neighbors is equals to 4. If you just do like this 4, then let's see how much is the 95.71%. Earlier it was 95.75%. Now let's just say 7. How to know? Let me just end this. This means cut this. 95.51%. Okay. Now how to know like what value of k means n neighbors should be there? It's 95.28%, means the bigger the k value we are giving. So you don't want to do like, see, it's 94% now. So you don't want to do like always changing the value just to see. Okay, you don't know now, like see 12, it's now again 95%. So you just don't want to do like 1 and then again do, and then 2 then again do. So let's just make it automatically, like to show us what k value should be there. Okay, so here we need to write k range. Here we're gonna know what value of k is best to find the better accuracy. Okay, or in what value of k accuracy gonna be the best. So I'm gonna explain you. Just give me some minute. Okay, scores equals to, just give me some minute. Just let me just write say small coding. Scores list blank, scores blank, dictionary gonna be blank also. For k in k range means here I'm gonna explain you. K range is 1 to 26, means we're gonna write a code to first, like same coding gonna be there. Okay, let me just copy this and just paste this, and here will be what k. Okay, b is first of all from 1 to 26, means 1 to 25. Okay, 26 here is means n minus 1. Whenever you give range now, so it in Python it acts like 1, means from 0 or initial input comma n minus 1. So from 1 to 25, first it will this k. So for k in range 1 to 25, it will put the value of k from 1 and then train the model. Then it will test the model, it will predict the accuracy score. Okay, and it's gonna do it for, like, see, let me just write it completely, then I can explain you better. Prediction x test and accuracy score. Here, and some people might have just understood already. K and one more, this say scores list dot append accuracy score between this see, training is going on. Now what it is doing is, here now first it is putting k equals to 1. Okay, now it is training, it is predicting on x test std. Okay, and then it is calculating the accuracy score, and it is appending those accuracy score, means it is putting those accuracy score in this empty list. Okay, and here in this line also scores k, here scores. Okay, and it is putting that accuracy score here also, and in next line in list also. Why in list? Because we want to plot now, so we can't plot using dictionary, so we need list. Okay, I'm just be with me. Okay, so what it is doing is, First, it put k is equals to 1. It trained the model, it predicted, and then it checked the accuracy score, and it appended that score in dictionary and in list also. Okay. Now, k is equals to 2. Training, testing, and whatever is the accuracy score, it appended here. Means accuracy score 1, comma accuracy score 2. Now, k is equals to 3. Training, predicting, and accuracy score, whatever the accuracy score of k is equals to 3 is, it appended here and here also. Means accuracy score 1, accuracy score 2, comma accuracy score 3. So it will do like it just did from 1 to 25. Okay. Now let's just see this dictionary scores. See, for k is equals to 1, the score is 96%, but never ever put k is equals to 1. This is the worst case scenario. Okay. Always just never put, because if you just put k is equals to 1, means it will just find the most nearest data and it will just decide that yes, I belong to this class. So it is just like worst decision. Okay. It is just because this input data will just see only one data, one nearest class and not other. Okay. So this is a worst case scenario. So always take multiple inputs. Okay. So always go from 3 at least. Okay. From 3. Okay. Not 1 but from 3. So here is the dictionary, and in list form you can just see like this. You can just actually do like this in list form. Why we need both? Because in dictionary we just wanted to show, okay, here like for one we got this in just like this, but using list you can actually plot this data in like just see, okay, plt dot. Using dictionary you can't do, no, because matplotlib does not support. In y-axis we want k range, okay, and in x-axis we want k range, and y-axis we want score list. Just see. In x-axis we have k range from 0 to 25, and y we have scores list. Okay, so you can say for 1 we have a score of more than 96%, but it's not good. Okay, so for actually go for 3, at least 3 you can say. Here you can actually visualize it like this, no? So for this one we should choose, and this belongs to about 3 or 4, I think 3. Okay, and score is just below 96%, and it's good because other than that accuracy is getting down. Okay, so if you choose 25, then you will get accuracy of almost 93%, you can say. Okay, that's also not good. So let's choose and neighbors is equals to 3. Okay, here also we can see for 3 we got accuracy of 95.75%. okay, so don't go for 1 or 2, take actually odd number input, not even but odd, as long as possible. And other than that accuracy is decreasing. So let's go for only and neighbors is equals to 3. okay, and we just predict on X test and see 95.75. this one is better. Okay, now we did it, and at last let's just find it on custom data. Okay, just like we did on this one, xnn, just like we did in this is numpy dot array and second list. Let me just copy paste that. Okay, let's just copy it. Decision tree's answer was employee will leave. Okay, so I'm just not gonna do that much. Means sorry, we're just gonna see and we need to scale down this data also, because the difference between you can say G1 and 500 is huge. Okay, and why we give 500 here? For what parameter? I just wanted to see average monthly hours 500 now. Okay, for second it was second now. So we need to scale down this data because we have trained it on scale data, so we need to scale down this data also. Okay, so xknn std I'm naming it, and how to do it? Simple. sc dot transform again. Transform what? xknn, and see np is not defined. What, seriously? Where I did I just ran this what you can say Jupyter notebook now. I don't know where this went. That's strange, but alright. Okay. So I don't know why it happened, but alright. So so just see the xknn std. See, 1 has become minus 2.266 and 500 is 5.99. Difference is not that much huge. Okay, just see the difference. 1 to 500 is super huge, but see the difference of like minus 2 point, or see the difference of like 1.15, and between 1 to 5 it's not huge, but here 1 to 500 is super huge. So that's why I need to scale down this data. Okay, to predict also, because we have trained it on scaled data. So that's why. Now how to predict? Simple. xknn I'm naming it prediction. Prediction on what? knn dot predict on xn and model dot predict in what? In xknn std, means predict on this and store the data here. Okay, and now let's xknn prediction 0 means employee will not leave, employee will stay. That's super strange. In decision tree we got what? For the same value we got, where it is, employee will leave, we got in decision tree. For same data we got employee will leave now. So there is more kind of misclassification. sknn prediction, let's just see for like 50. I don't know, I just give it super not 500, but means 500 again. Let's just increase the, what is the 8 here. Okay, I'm just trying, just be with me till last. xtest dot head 1 150 according to this number of projects 3 na, number of projects 20, time spent in company 10, work accident 6. Alright, promotion last 5 period 0, satisfaction level 0. You can say what, 10%, and in last evaluation it was 0.30. okay, salary, now in salary we low. Okay, 1 is low, and department number is, I don't know, whatever it is. Alright. Okay, now employee will leave. According to this, now employee will leave. Okay, now again you can just simply write like in a much better way. Let me just copy paste that. This one here also. No, let me just fully copy paste this one. Employee will leave. Okay. Now last part is we just need to plot the accuracy score of decision tree and KNN, means just as a visualization thing, okay, like just as a data representation of which algorithm did better, okay. We just can visual plot that, like, just be with me. Algorithm is school DC decision tree, and another one is KNN and their scores, okay. This is the last part we are doing, their scores. So what was the score of hey, I didn't found out the alright, leave it. So accuracy DT, accuracy KNN, and what I gave name to DT of decision tree, it is only showing of KNN. I didn't give any name. Accuracy DT, I should name it. Accuracy DT. First to this, and here you can call this accuracy DT 97. Okay, accuracy DT is the name. Accuracy, okay. We gave it for only KNN, accuracy DT now, and accuracy KNN. Okay, now alright. Now SNS dot set not we need to write this, but here only SNS dot bar plot of x-axis we want algorithms and y-axis we want scores, okay. See which one did better, and you can actually, you should do it in a much better way. plt dot x label should be your algorithms, and in plt dot y label should be, means label, if you want to give label, should be your accuracy score, and this line if you want to remove, then plt dot show. See algorithms here, decision tree did little better, of course we just saw, because in decision tree accuracy was like 97%, and in KNN we got accuracy of like almost 95%, okay. So as a data representation you can actually show this kind of thing, like just increase the number of models if you are working with more number of models, and it will just plot like decision tree, KNN, SPM, logistic regression. So your data representation will look much better, okay. Not in just terms of codings, because if your client does not know the coding stuff, you can just show them this graph and they will get to know that yes, decision tree did better in this case, okay. So that was all about this project. If you like this tutorial, then please press the like button, subscribe to my channel, hit the bell icon, because and follow me on Instagram and TikTok also, and I'm gonna bring you more and more projects like this, okay. Thank you very much.